In professional bowling, about 60% of the shots are strikes. But what about the rest of the shots? There are a little over 1,000 possible spare configurations, and players convert the hardest less than 1% of the time.
So what's the most difficult spare of all?
Well, there are a lot of notorious spares out there. But today, we're going to be looking at the most notorious of all, the 7-10 split.
Now look, some of you may have noticed that this episode breaks with our format a little bit, because unlike previous feats that we've looked at, people have actually hit 7-10 splits.
Oh, look at that extra frame.
Here's the thing, nobody on Earth can hit a 7-10 split predictably or reliably, and that's because that split is even harder than it looks.
So today, we're going to look at why converting the 7-10 split is really, truly, almost impossible. To find out what it takes, I played a few frames with a professional bowler.
I believe the 7-10 is the hardest spare split conversion to make in bowling.
Tried hacking the game with a bowling robot, and crawled inside the jaws of a pin setting machine to find out what really makes the 7-10 split the most difficult spare of all.
This has been turned completely off, which I am grateful for.
But first, I went bowling.
I've made the 7-10 3 times in my lifetime, and I'm 43 years old. I've been on tour for going on 19 years.
That is 10-time national title holder Wes Malott. We met up with him at the U.S. Bowling Congress in Arlington, Texas.
Do you have any pro tips on how to convert this thing?
Well, I'll tell you one thing. In order to make 2, you got to hit 1.
In other words,
that's
accuracy
really
is
solid.
essential.
Come on.
It's also not my strong suit.
Come on! It's hard to hit the 1.
At least for me it is. Malott can hit whatever pin he wants almost every time. But there's more to converting this spare than accuracy. And to fully appreciate why, it helps to understand the anatomy of a bowling lane. It's 42 inches wide and 60 feet from the foul line to the head pin. That's pin number 1. The 9 remaining pins are numbered like this. Each pin stands 12 inches away from its neighbors, creating a pattern of equilateral triangles. 2 gutters run alongside the lane and trap the ball if it strays too far left or right, removing it from play. Bowling just boils down to angles. When the ball and pin collide, the pin bounces in a direction perpendicular to the tangent plane that intersects with the point of contact. So if you hit the pin here, it'll bounce here. Hit it here, it'll fly here, and if you hit it here, it'll go this way. That means that in order to send the 7-pin flying across the lane and into the 10-pin, or vice versa, in theory, you need to hit it right here. Here's the problem. It is impossible to get a bowling ball far enough outside the 7 or the 10-pin without it first falling into the gutter. There's just not enough room. That makes the 7-10 split the only spare in bowling that can't be converted with ball and pins alone. To pull it off, you actually have to bounce the 7-pin or the 10-pin off the machinery behind the pins. And the more power on the shot, the better. When Malott goes for the 7-10 split, he throws at about 22 miles per hour. That's harder than he usually does. And he often gives it a little bit of forward spin so the ball won't hook and lose speed. But there's one more essential ingredient for converting the 7-10 split: luck. Even if you hit the pin hard enough, and even if it heads toward the pin setter at a good angle, there's just no telling how it's going to ricochet.
Without some kind of lucky bounce in the machinery in the back end, you're just not going to convert it.
And that's because this isn't like banking a shot in pool.
For starters, the pins have a funny shape that causes them to bounce around unpredictably. But you also have to consider the barrier behind the pins. It's a curtain, not a wall, which means that it moves, and anything bouncing off of it is going to ricochet around even less predictably. And some of those curtains move more than others. Here's what I mean by that. Okay, so unless you work at a bowling alley, you've probably never been back behind here. This is a pin setter. It's what collects and sort of repositions all of the pins every time you're bowling. And the piece that we want to look at is in here. Okay, so this is an older model pin setter. It's anchored in 2 places, once up here at the top and again down here along this more solid bumper section. When you're trying to convert the 7-10 split, the goal is to bounce either the 7-pin or the 10-pin off of these surfaces and into the opposing pin. Now, what you might have noticed when I touched it is that this curtain has some give to it, and that movement actually reduces the energy of the pin bouncing off of it, which makes it tougher to ricochet into the other pin. Here's the thing. On newer model pin setters, this curtain moves even more. And when we were at the US Bowling Congress, we actually got to see what one of those pin setting curtains looks like. On these newer mechanisms, this curtain is only attached at the top, and so it swings completely freely like a doggy door. And then the pin, instead of bouncing, all of that energy just gets absorbed into the curtain.
All of which means that, in the end, when it comes to the 7-10 split, your best bet is to hit either pin as hard and as consistently as possible, and then just hope for the best. And when it comes to consistency, no bowler on earth is as reliable as this one. Meet Earl.
That was mildly terrifying.
Earl is our staff bowler here in the equipment specs department. He's a robotic arm, and he throws bowling balls very, very, very well.
Earl can put a bowling ball pretty much anywhere you want, at up to 24 miles per hour and at spin rates as high as 900 rotations per minute. That's triple what pros put on their shots. And once you've dialed in all your parameters, Earl can roll the same shot over and over and over. Normally, the US Bowling Congress uses Earl to test equipment, but today we're going to use it for an experiment. The goal? To see if Earl can hit a 7-10 split.
Come on, Earl. I'm changing the trajectory from 1.7 to 1.2.
To increase our chances of hitting the spare, we decided to let Earl bowl on a lane with an older model pin setter with a fixed curtain. We tried bouncing into the side, at an angle towards the middle of the curtain, and even got the pin to double bounce off the ball. And while some of our shots looked like they might have come close to converting the spare, we never managed to actually pick it up. Earl might be powerful and consistent, but not even a robot can engineer luck.
So if you bring all of these factors into consideration, you wind up with a conversion rate on the 7-10 split of just 0.7%. But there is a spare that players hit even less often.
Everyone talks about the 7-10 split. Is that actually the hardest shot?
This is data journalist Ben Blatt. A few years ago, he analyzed close to 500,000 frames from the Professional Bowling Association to try and figure out what the hardest shot in bowling really is.
So you analyzed close to 500,000 frames. What did you find?
Spare conversion that was picked up least often is a shot that actually has a nickname called the Greek Church. It was picked up about 0.3% of the time compared to the 7-10 split, which is about 0.7% of the time. So they're obviously both extremely hard to pick up, but the Greek Church statistically was converted much less than the 7-10 split.
If you've never heard of the Greek Church, here's what it looks like. For right-handers, it's when you leave the 4, 6, 7, 9, and 10 pins. And it's the mirror image of that pin arrangement for lefties. It's called the Greek Church because if you look at the pins head on and use your imagination, they look a little bit like the spires of an old cathedral. To convert it, you need to hit all the pins on one side while sending at least one of them across the lane to knock over the remaining pins. It's a highly technical and very risky shot. If you miss, which you probably will, you earn far fewer points than if you go for the 3 pins you know you can hit. That second strategy is called going for count, and bowlers typically do it when they encounter difficult spares.
If you're in a game time scenario, strategy more often than not calls for just picking up the 3 on the right.
Most of the time, yes, you're going for count and you're going for the 3 on the right.
But let's say you're going for all 5 pins. Is the Greek Church actually harder than the 7-10? Not according to Malat.
I think the 7-10 is harder than the Greek Church because the Greek Church, you can shoot at it and you've got a pin that can slide across to make the other pins. A 7-10, they're even farther apart and it's virtually impossible because the lane is only so wide, you can't hit that side of the pin and get it to slide over to the 7 pin.
To prove his point, Malat agreed to try converting the Greek Church. He struggled at first. It is, after all, a really difficult shot. But it only took him about a dozen attempts to finally convert the whole spare, and he came pretty close 3 or 4 times. We saw similar results from Earl. Once it was dialed in, the robot was able to convert the Greek Church about 40% of the time. But neither our human bowler nor our robotic one could convert the 7-10. So if the professionals still think the 7-10 split is harder than the Greek Church, why did it come up less often in Blatt's study? Again, it boils down to strategy. On the 7-10 split, it's the same shot whether you're trying to knock over 1 pin or 2. But on the Greek Church, it's 2 different shots. If you go for count, you'll probably pick up 3 pins. But if you try to convert the spare, you're going for these 2 pins right here. And there's a good chance you'll walk away with just 1, or maybe even none.
Even though converting the Greek church is technically easier, it is almost never worth it to try in a game.
It's virtually impossible, almost impossible, to be able to slide over and hit both of those pins simultaneously.
Which is probably why it showed up less in the study than the 710. The point is, there is an important distinction between the rarest shot in bowling and the most difficult, a title that still belongs to the 710 split.
Because remember, without that pin setting machinery behind it, you cannot convert the 710 split. So unless that machinery changes in some way to bounce pins more reliably or predictably, the 710 split will remain almost impossible.